Hey guys, can you hear me?
Yeah.
Yes, Suresh.
Yes, Suresh. Yes.
Yes.
Very good morning and good evening. Just give me a moment, folks. We'll get started. Um, just a quick check, guys. How many of you were there in demo a day before?
I was there, Suresh.
Hmm.
Yeah, hi Suresh. I joined today.
Suresh, me also joined today only.
I think I should be asking the questions rather than answer who joined today, who were not there in the demo. I see a couple of folks.
Yeah. For me, today is the first class. This is Harish.
Hmm.
Can you hear me?
Yeah, I can hear you, Harish. Yeah. So I just want to see the count, how many of you were joining today. Okay, that shouldn't be a problem anyway. Demo is all about making you comfortable. That is the case with next four sessions too. Okay, so let's get started. I know I haven't introduced myself during the demo, so let me introduce myself. I'm Suresh. I'm having 12 plus years of experience into data engineering. I have got a chance to work with multiple companies on multiple domains. Predominantly, I have spent time in financial domain, guys, be it an asset management company, bank, of asset management and banking, I would say, and got a chance to work with digital marketing projects for Google as a contractor, though not a full timer, and have dealt with other domains as well, like retail and insurance domains. Started my career as a Hadoop developer in 2012. So we were writing all the MapReduce codes on big data, distributed computing, and Hive queries. Then transitioned myself into Spark. Uh, Not a choice, but that's how it was. Whatever we have written in MapReduce have to be converted to Spark at a later point in time. And from 2017, 2018, people started talking only about cloud, and that's when I have started my career on cloud. Started with Azure, but I do have hands-on with Azure, uh, GCP, and then AWS. I would say Azure most of the time, and then GCP. I have spent a good amount of time on GCP data services, and very few time. I mean, not not much with AWS. I have spent around 8 to 9 months on AWS. I haven't really gotten chance to expose I mean, explore AWS as much as I did for Azure and GCP. So that's a brief introduction about me. And talking about my training experience, I have been training folks since 2016, guys. Started as a Hadoop trainer, then I trained folks on Spark. Now I'm training folks on Azure data engineering and also Python. Okay. So I know most of you have introduced yourselves yesterday, but people who joined today, I just want to introduce yourself in the chat window in this format. Your name and the technology you're currently working on and your experience. Say, for example, I'm data engineer and I have 12 years of experience. Say, for example, if you're a fresher, you can just mention your name and then fresher. Let's take a couple of minutes and we'll get started. Pradeep, 14 years Oracle. Hey, hi, Pradeep. I see a couple of others as well joining today. Sai Manuel, just a 5 years. Hi, Sai.
Hi, Suresh.
Chindan, 15 years in BI reporting, Cognos and Power BI. Okay. Hi, Chandan. Hi, Dilip. 17 years, 14 years as DBA, 3+ years as GIS engineer, Global Information Security. May I ask, Dilip, which organization you are working for? I'm
Uh,
referring to GIS
yes, I'm currently working with Dish TV, previously with fintech and data center also.
Mhm.
It's an entity NetMagic and RappiPay. Previously, I was with. Currently, I'm working with Dish TV.
Got it. Great. Harish, .NET Architect, 25 years experience. Hi, Harish. Rajiv, 14 years SQL developer, 14 SQL developer. Okay, Oracle 14, 5 years. Great. Hi, Rajiv.
Yeah, hi Suresh.
So, your batch is really exciting, guys. I mean, now I could definitely sense a reason to wake up so early in the morning in India and then push myself to take these sessions. Most of you are coming from SQL background. Good to see that. Okay. So let's get started with our technical discussion. So people, I know most of you are already coming from this data background. So I want you to be little patient for first 2 to 3 sessions, guys, because all my sessions starts from layman terminology, very basics, just to cater the course to everyone who are coming from different backgrounds and then, different experience ranges. Okay, but let's try to make this session as interactive as possible and let's start having fun. Okay, so the name itself, data engineering. So what exactly is data? I know we have discussed this during our demo, but demo wouldn't be considered as a part of sessions, guys. Okay, so we'll start everything from the scratch and now we'll deep dive. Okay, so yeah, what is data? What do you know about data? We have been hearing about this term, right, on a daily basis. Mhm.
It's a piece of information.
Piece of information. Okay, what else? Collection of raw facts. Correct. Bookish definition. How else can you interpret this? Just give me a minute, guys. Yeah. So let's continue. The bookish definition of data is a collection of raw facts. Okay, so facts I would always contribute it to attributes. Okay. I mean, let's deep dive one step deeper and then try to understand this definition, right? Most of the times when I asked for a definition of data, I usually get the definition of information, or maybe somebody says that, data is nothing but information or useful information. But that's not the case, guys. Okay. Unfortunately, we use information in the wrong context in our day-to-day life. Okay, so wherever we have to ask for data, we ask for information. So do you have any information about this person? No, that's not right. Okay, So information is nothing but processed data. I'll talk about that a little later, but talking about data, right? Data is nothing but a collection of raw facts. What exactly are these raw facts? Okay, so you take a person, the person's raw fact could be person name, person height, person weight, the location where he is coming from, and all his personal details. This is what we call data. You take a product entity. So when you take a product entity, you will store some attributes about it, like product data. You take a retail domain and then product data, where you'll have a number which can uniquely identify that particular product, and then the product name, and then product manufacturer, product price, product image. These are all attributes, guys, and this is what we call as data. Likewise, you take customer data, you'll have customer first name, customer last name, customer addresses, and then, customer email ID, customer password, whatnot. Okay, so these attributes are what we refer to as data. Okay, information is a little different. Information is processed data. Okay, yesterday in the demo, I was giving an example, right? Let me repeat the same. So, say for example, if I was given a list of marks of 100 students, I'll not be able to interpret anything. Okay, so maybe just by looking at the sheet I was given, maybe I can pick a guy and then I can just check the marks he got. Subject 1, subject 2, subject 3, whatever it is, right? But when somebody comes to me and tells me that, boss, the average percentage of this class is 70. Okay, so that is where I can interpret something, meaning, you pick any person from the class, his average or his percentage would be in and around 70%. Okay, it doesn't mean that that is applicable to everyone. There could be outliers, people who got 90, 95, and there would be people who got 30, 40 as well. But whenever I talk about this metric average, most of the class falls into that segment. Okay, so this is what we call as an information. Information is processed data which would let you interpret something. As simple as that. That is the difference between data and information, guys. Okay. And now we'll talk about the classification of data. Okay. So there are different classifications. First thing is transactional data versus historic data. So this shouldn't be the first. The first one I would say is based on the how it is structured. So whether it is structured or unstructured or semi-structured. And then we have transactional versus historic. Okay, and maybe we'll stick to these two things: structured, unstructured, and then semi-structured. Okay, any idea what exactly the first classification is? Structured versus unstructured versus semi-structured.
Structured is kind of some data stored in a relational database or like tables or something in the form of tables.
Mhm.
Whereas unstructured is kind of is the raw data in files, stored in files or something.
And
Semi-structured, I don't know. Sorry, don't have an idea what exactly is semi-structured.
no problem. So Pradeep is correct to some extent, guys. Okay, but let me give you a clear understanding on these three classifications. This is really needed. I have couple of pings as well. Unstructured is like social media data like videos. Okay, that's correct. Okay, but let me explain. So we'll start with unstructured, the basic one. So, maybe the definition, the way I'm going to define this might sound funny. Unstructured data is something which is not structured. Okay, so what do I mean by that? Not structured. That is already being indicated by the name itself, right? So what is the structure we are referring to? Structured company or customer data. Okay, let me explain. So I'm gonna take a simple example. Maybe I want to store a student data, okay, in an unstructured way. Okay, so talking about storing the student data in an unstructured way, it will have a lot of verbose, guys. Okay, so what do I mean by that? A student named XYZ. So for example, I'm storing student marks. A student with name XYZ have secured X marks in subject 1, Y marks in subject 2, so on and so forth. Okay, there's Z marks in subject 3, so on and so forth, and managed a total of the sum of X plus Y plus Z plus whatever it is, and a percentage of whatever it is, so on and so forth. Okay, so that's how the data is typically stored in an unstructured format. So basically, it doesn't have any structure attached to it. Okay, so the news you read in blogs and the social media data, or the multimedia data like videos, images, right? So all of them are considered to be an unstructured data. All of them are considered to be an unstructured data. Okay. Say, for example, what do I mean by adding structure to this? So, now looking at the data, whatever we have, I mean, looking at the statement, whatever we have, what I can interpret is few attributes. One is name, the important attribute, and second one is marks, like subject 1, subject 2, and then subject 3, subject 4, maybe subject 5, and then subject 6. Then another important attribute is total, and another important attribute is percentage. And yeah, maybe this should do for now. Okay, now, what I can do is I can store actually this data in a form of table. Okay, so what I can do is maybe I can create a table like structure, name, subject 1 marks, and then subject 2 marks, subject 3 marks will take only 3 subjects, and then total, then we have percentage. And then we can store data in the form of rows and columns. Suresh, some 75, 70, and then 70, 210, 215. And then this one would be somewhere around 72, something like this. I'm just, giving some random values. 70, 105, and then it would be somewhere around 32. And then Naresh, 85, 90, 90, and then 270, 265. This would be somewhere around 87. Okay, now if you see, this is looking like a table, which is having some rows and columns. Which is having some rows and columns. Okay. Now the first row is what we call as header row. This first row is what we call as header row. Okay. So which is actually defining what attribute you're storing. Name, and then subject 1, subject 2, subject 3, total, and then percentage. And each row would talk about one person, guys. Okay, so each row would talk about one person. Suresh, 75 is his subject 1 marks, 70 is his subject 2 marks, 70 is his subject 3 marks, and then his total, his percentage. So these horizontal ones are what we call as rows or records. Okay, and these vertical ones are what we call as attributes. Name is an attribute, S1 is an attribute, S2 is an attribute, or columns. Okay, and this is how we store data in a table, and attaching a structure to it. Now we are talking about structure. What structure we have added to the data that is there in unstructured format? these rows and columns. And when we talk about that structure, that is what we refer to as schema. Schema is nothing but the column names. This name, subject 1, subject 2, subject 3, total, and then percentage. Not just column names, but also data type. Okay, so what type of data we are storing? This is a string data, and then this is an integer data. And I think these are all integer data. Okay, so the column name along with the data type is what we refer to that schema. And that schema is nothing but the structure we are adding to this data. Okay, and then we have a tool called as an RDBMS. Then we have a tool called as an RDBMS. Okay, relational database management systems. And this RDBMS tool is designed to store your data in the form of tabular format, which is the structured way. And it also provides with something called as SQL. It also provides you with something called as SQL, using which you can actually query from the tables. Okay, so what is this querying? Let me again give you an example. Let's say we have stored data in the unstructured format in files. We have stored the data in the form of unstructured format in files. You can probably pick any file, Word document or Notepad or whatever it is, .txt or whatever it is. Okay, and let us assume, we have 120 students in a class, and we have stored the data of all the 120 students in the same document in the unstructured format. And maybe I want to pick all the students who have secured 95 plus marks, 95 plus marks in subject 2 and reward them. Okay, so how will I be able to do it? I literally have to go line by line manually and then see all the students who have secured more than 95 marks in subject 2 for all the 120 students. Okay, so it could be a 3-page document, 4-page document, doesn't really matter. Now just imagine I want to see the same thing at a college level for 700 students. Now just imagine I want to see the same thing for university at an university level. Okay, so which would have close to 1 lakh students. Okay, so it's actually becoming a bigger problem when it comes to querying your data, or when you want to see something from your data, it is actually becoming a problem. Okay, so just to solve this problem, we have this RDBMS and then structured format, where you can actually store data in the form of tables. And talking about the SQL, right? This is the easiest ever language I have ever seen. Select star from, let us assume the table name is students. Every table has some name attached to it. Select star from students, where subject 1, subject 2 is greater than or equals to 95. This is so easy that everybody can understand just by looking at it. You might not be aware of SQL earlier, but you can still interpret something. Boss, we are selecting something from the students. My bad. Where subject 2 is greater than or equals to 95. So you will definitely be able to interpret something even if you are looking at this for the first time. That's the beauty of SQL, guys. One of the easiest ever language which would help you to query your data. Okay, and RDBMS is a tool which would help you to store the data in the form of tables, and it also provides you with something called as SQL, where you can using which you can actually query your data. Okay, so let me take a pause. Are we good so far?
Yes, sir.
Okay. And since this is our first session, I just want to uh, tell you something, guys, which might help you too. Okay. So in this session, we have right now close to 20 students, right? maybe, apart from organizers, I would say we have 18 participants. Okay. So after 2 months, I'm not sure how many of you will attend till the last session. Okay. But, after 2 months, if you ever want to talk to me, connect with me to discuss on anything, if you really want, you don't want to be introduced again, then start responding to the queries and start being interactive, guys. Okay, because I will usually take back-to-back batches. So for example, once this batch is completed, after a couple of months, I'll start a new batch. So it will be very difficult for me to remember your names if you are a mute spectator in the batch. Okay. So for example, yesterday when I was taking this demo, I was able to recognize one of my participants from my previous Python batches, Sunita, because she have been very interactive in that session. So if you are interactive, if you are talking and then answering to the queries, right, I will definitely remember you guys. You don't have to introduce yourself to me whenever you want to meet me, even after these sessions, even after a year. Okay. So please, please, please try to be as interactive as possible. You don't have to unmute yourself and talk. Okay. You can ping it in the chat window. Okay. And if you are shy to ping it to everyone, you can ping it to me in person. In your chat option, you'll have an option to ping it to me in private. Okay. So please try to be as much interactive as possible. Okay. Now, moving back to our classification, right? The third classification is semi-structured. So now talking about semi-structured, the name itself is indicating, right? It's not completely unstructured and also it's not completely structured. Okay. So it's lying somewhere in between structured and unstructured, meaning usually you will be able to, you will still have some structure attached to it, but the data is not typically stored in a table. I repeat, you will still have some structure attached to it, but the data is not typically stored in a table. Okay. So what could be the examples? JSON files, XML files, CSV files. These are all, the typical examples for semi-structured data. So coming back to one of the response I got from one of our participants. So not all the data stored in files is unstructured. I repeat, not all the data that is stored in files is unstructured. Okay, it could be semi-structured too sometimes, provided if your file type is one of these. Okay, so what do I mean by this? So for example, you take a CSV file, okay, and you can store the data in the same, by attaching some structure, um, name, and then let's say subject one, and then subject two, then subject three, maybe total, and then percentage, something like this in a file. Name is Suresh, subject one is 75, 75, 70, 210, 220, and then percentage is somewhere around 72 approximately. So this is how typically data is stored in CSV files. Okay, this is again a text file with .csv extension. Text file with .csv extension. Okay, and then we have JSON file where the data is stored in a JSON format. And this is typically looks something like this. In a key value pair, basically name, and then name is Suresh. Since they are strings, I'm enclosing them in double quotes. And then subject one marks 75. Key value, and each of these key value pairs are separated by commas, guys. Okay, and then subject two is 75 again, comma, and then subject three is 70, comma, And then subject 4. We don't have subject 4, my bad. I would say total. Total is 220. And the last one is percentage. Key value pair again, 72. So this is how your typical JSON data would look like. And again, this is stored in a text file with extension .json. Okay. And say, for example, same thing you want to store in XML. It would look something like this. Each record can be identified by a record tag. It is custom. It need not be record every time. It depends on how you want to store it and how you define it. Okay. And each record tag or row tag, or you can give your custom name. I can just give Suresh. Okay. And then attribute, value, and then close attribute. Okay. So these are what we call as tags. So here the structure is attached in the form of tags. S1, 75, and then S2, S1. This is the end tag. They look similar to your HTML tags, but these are all custom tags, guys. They are not predefined. And then subject to 75, subject to close tag. And then subject 3, 70, and then subject 3 close tag. Likewise, we have total. And the total is 220. Total. Okay, and then percentage. Then you have percentage 72. And then close tag. This is how your XML data would look like. Okay, so the structure here is attached in the form of tags. Okay, so coming back to your question, Parmila, he is fixed with file formats are unstructured or semi-structured. Semi-structured. Because you are attaching structure in the form of a width. Okay, but they are text files at the end of the day. Make sense?
Yes, Suresh, thank you.
Yeah. So just a minute, guys. Yeah. So this is the difference between structured, unstructured, and then semi-structured. Are we good so far?
Yes, Suresh.
We do, Rajiv. These are the few examples. .txt files can also have semi-structured attached to it. Okay. Flat file, like I was mentioning, right, Sunita, it all depends on what data you have. Say, for example, you can have the comma separated values in .txt files too. You can have tab separated values in .txt file too. It need not be TSV all the times. Okay, it all depends on how your data is present in your file. You have some structure, but they are not typically stored in a table, then it's semi-structured.
No, just this is a text file, an XML file, and JSON file. This is a type of data, right? And is there any other format we can consider as semi-structured?
It depends on entirely depends on the data you have in the file, Rajiv.
Okay.
Okay, that's the example I was giving, right? So for example, if the same data is present in .txt, it is still a semi-structured file. Just with the extension, you cannot say that it is an unstructured file. Okay, you can still deal with all the CSV libraries for this file. Make sense?
Right.
Okay. Likewise, here CSV meaning by default they are comma separated, but you can also have the other delimiters too. Okay, but we can talk about that, little later. But are we good so far on this classification?
Yes, Suresh.
Perfect. Now, moving on. Transactional versus historic data. So, what is this, guys? Transactional versus historic data. Any idea?
Transactional data is a real-time data when like card swapping and historical. This is like how many types of customer has swapped the card. So that's type of data is as a historical, we can say.
Perfect. Any other examples or anything else anybody want to add to what Rajiv said?
It's kind of OLAP and OLTP, like online transaction data and online analytical data. Like
Yes,
historic data is used to like kind of analyze purpose, and transaction is kind of real time data that is coming in.
yes. What else? Now, let me explain. Okay, and I'll give you a few thumb rules using which you can actually categorize them. Transactional versus historic. Transaction data is something which you need on the go when you're operating with some website or some business process, as simple as that. Okay, example, login data. Okay, so the moment you give user ID and password, it will have to authenticate you and then log you in to the portal, right? And then maybe you want to purchase something. Guys, whenever you're not talking, please try to be on mute so that it won't impact the recordings. Okay. Otherwise people will have a lot of fun hearing what's happening in your household while they're listening to the recordings. Okay, just kidding. Yeah, now talking about this, right? Maybe you want to fetch details about a particular product you are looking for. At the moment you type a search keyword uh, in your portal, in any e-commerce portal, could be Amazon or Flipkart or whatever it is. It will be displaying all the product data. Again, it has to be transactional. The moment you add it to cart, the cart information or the cart details has to be transaction data. Okay, so anything that is helping you to do something in the real time is what we refer to as transaction data. Okay, and now talking about the historic data, right? This is something which you don't need in the real time, but it is needed for analytical purpose. So, what would really help me? How analytics would help a company to grow? I can pick numerous examples, but let me pick the easiest one, which you see on a daily basis. So whenever you are purchasing a mobile phone, your e-commerce website won't let you purchase phone alone. It will come with some recommendations. It would be great if you can purchase cover as well or screen guard as well. Okay. So, that might not be the case with other countries. At least in India, I'm talking about this. But I was talking to my brother who is staying in Canada. He was mentioning that let's say let me pick an example about which we were discussing. Say for example, in India, if you purchase iPhone 15 or iPhone 16, whatever it is, right? So here the recommendations would be screen guard, which is tempered glass, and then case. If it is in Canada, they won't recommend cases directly, but they would recommend the protectors for your iPhone, both front and back side. Okay. So my brother currently is using those covers. I mean, that really caught my eyes when he visited India in December. Okay. And then when I did small research, the recommendations is not generic across the globe. So different regions, different recommendations. So all this comes from your purchase history. So whenever you are making a purchase, the data would be stored and that data would be analyzed in order to recommend these products. It could be by region, it could be by geographical location, it could be by ethnicity. There are a lot of things that would decide. Say, for example, what are the products that are being sold in India would be way different from products being sold in the West. Okay, say for example, nobody would recommend a jacket, a fleece jacket in India. We can't even survive wearing that for a few minutes. Okay, so these are all the things that won't happen by just by looking at your data, guys, because you cannot analyze like GBs and TBs of data just by looking at them. Maybe few hundreds of records, you can still interpret something looking at them. But when you have TBs and petabytes of data, you'll not be able to do anything manually. So that's where the data engineering and data science comes into picture. But let's not go till there. You're talking about those analytics. This is really needed. Really, really needed. Having this historic data and doing all these analytics. Okay. So anything that you need in real time is transactional data. Anything you need to analyze and improve your business is historic data. Okay. So how long a data can be transaction and when it can be moved to historic? It depends. For few data, it could be seconds where it can be moved to historic, but few uh, data, it can be still transactional for months. And it can be both transactional and historic too sometime. Okay. So now we have different tools to deal with them, guys. So generally transactions are referred to OLTP. The full form of OLTP is online transactional processing. We call it as OLTP engine. And then talking about historic, we have OLTP engines to deal with that. Online analytical processing, analytics or analytical processing, whatever it is. Okay. So we do have different tools for this. OLTP, we deal with databases, RDBMSs. And OLAP, we deal OLAP processes in a data warehouse. Okay. And the data modeling is also completely different. Say, for example, in OLTP, we use a different data modeling. Like you might have heard about normal forms, first normal form, second normal form, third normal form, voice code normal form, whatnot. And the data warehouses, we have a different structure altogether. Okay, or the model altogether. We follow the star schema, snowflake schema. Okay, again, I'm not deep diving into those things today. Okay, but this is what it is. And today's data engineering deals with this, whatever I have highlighted. Okay, now for you to be called as a data engineer, you will need to know about, to put it in even simpler, you will have to deal with any type of these data. What are the classifications we have uh, discussed so far, right? If you are capable enough to deal with any of these types, then you are a data engineer. That is what we are going to learn for next couple of months. What are the different steps we have? What do we do when a data type or a data format is structured, a data format is unstructured, or data format is semi-structured? How do we process it and how do we present it? How the stakeholders consume that data? Okay, so these are all the things which you are going to learn in next couple of months. Let me take a pause. Any questions? And talking about data processing, right? We have two types, batch and real time. with this classification, we will be wrapping up today's session. Okay. So any idea, batch and real-time processing? When do we do batch processing and when do we do real-time processing?
Batch processing, we collect some few, chunk of data, and real time, then we can row by row and real time data pushing, like example of OTP.
Yeah. Yeah. So whatever the responses I have got, be it directly or in messages, yeah, all of them are partially correct. Okay. Now, anything which is scheduled is batch. Anything which is scheduled to run is batch. As simple as that. Okay. It could be once in a day, it could be once in a week, it could be once in a month, it could be twice in a day, it could be every 1 hour, whatnot. But when something is scheduled, it's batch. Okay. So generally, whatever the analytics we are deriving, right? If those analytics are needed once in a quarter, once in a month, generally for that type of processing, right? We do batch processing. So for example, recommendation engine I was talking about earlier, it doesn't need a real-time processing. I don't need my recommendations to change every second. Okay. So it can wait until a day at least. So for example, at the end of every day, I will be running my batch to see if the recommendations got changed. So for example, people preferences have changed. Let's say Apple have come up with a replacement warranty for back case and glass. People will definitely stop using screen guards. Okay, so you will never know when the preferences of the customer will change, but still it can wait for a day. Okay, and let's say the real-time processing, it's exactly opposite, guys. Real-time processing is not scheduled. It runs continuously forever, all the time. Okay, so the best example I can pick for real time is Twitter trending. How many of you are using Twitter or X? At least you must have heard about it, right? These days, Twitter has become the main review portal for all the Telugu movies. Not sure about the other languages, but whenever a big movie is being released, every day in the morning, I mean, that day in the morning, fan war starts in Twitter. So these days, people left Instagram and Facebook. Okay. Yeah. Now, talking about this Twitter trending, this trending tags will change in real time basis, guys. I'm not sure how many of you have observed. And that too would be by region globally and then by your country too. Okay. So this would happen in real time. So for example, if you are receiving more tweets on a particular topic with hashtag, right? That would be shown in the trending. The top trending would be the thing which is talked, which is being tweeted on, mostly tweeted on by most people. Okay, so that's one example. And then stock marketing, real-time stock marketing. If you are into stocks and then you want to invest, whether you want to take a decision, yes or no, to invest in a particular stock, that could be real-time too. Okay, so these are few examples. Not everywhere real-time is needed. So that's the reason, at least in my experience of 12 years, 90% of the time I was working on batch processing and 10% on real time. That 10% is also in the recent past because nowadays people's preference is moving towards real time. Sometimes unwanted pressure from the superiors, even though the insights what were needed after a quarter, they want to show it now itself. Okay. Again, I don't want to get into those details, but yeah. So sometimes, somebody is doing, so we also have to do that kind of a things are pushing some projects towards real time. Okay, but yeah, I would still say batch occupies the majority space in the data engineering projects. Are we good so far? Great. If you can understand these 7 terms, this batch and real-time, transaction and historic, and then structured, unstructured, and semi-structured. If you understand these 7 terms, okay, and if you learn how to deal with these 7 terms, that is data engineering for you. As simple as that. How many of you agree? Data engineering is nothing but, understanding and dealing with the 7 definitions we have learned today. Yeah. Great. So let's stop here for today. And when we meet tomorrow, I'm gonna introduce cloud to you. I'm not sure how many of you already have that background of cloud, but tomorrow we'll talk about cloud, what cloud is all about, what type of cloud deployments we have, different types of services we have in cloud. And if time permits, I'm gonna show you the steps to create Azure account. Okay. So from tomorrow onwards, we will be moving into the cloud related topics, guys. Okay. And most probably Thursday and Friday, I'll be dealing with our first service in Azure, which is Gen 2, ADLS Gen 2. Okay. So that's a heads up for what's coming up in this week. I would let you go now and have a good night and good day for the folks joining from India. Thank you all.
Thanks, Suresh.
Harish, notes, I don't have anything to share, buddy, but you will be receiving the recording of this session.
Yeah, perfect.
Suresh.
Thank you.
Bye.
Okay, but guys, please feel free. During the session, if you see something interesting on my screen, take a screenshot because this notes will not be shared. Okay, because this is completely unstructured. There is no point. Okay. Cool. Thank you all. See you tomorrow.
Thank you, sir.
Yeah, thank you.
Bye.